Okay, so one of the first things that we're going to want to do is look at the rules for naming these alkenes, because I have a paper for you. There's no reactions on there, but what I want you to do is open up to page, okay, 340. So at the very bottom, it says 12.4. It talks about naming alkenes. Okay, and we've been working on that. But one of the aspects I want to mention before we get that far, look up halfway through page 340 where it says 1A and 1B. Okay, we're looking at this area right here, about halfway down. Underneath it says 1A and 1B. Okay, what is the name of 1A, do you think, on page 340? It is Pantene. So then 1A is Pantene, 1B is... Okay, now the reason I wanted to mention that from one of the very last things we said yesterday. So we know that 1A and 1B are both alkenes. No one would argue with that. But as far as symmetry is concerned, which one of those is symmetrical, which one of those is asymmetrical? Correct. So 1B is what we would consider symmetrical, even though it's not in the middle. It's 1A that is asymmetrical. If it's after the first carbon in these alkenes, we consider that asymmetrical. That is important for when you're dealing with a lot of these reactions. Okay? And like I said, I can't stress that enough. Even when you're looking at 1B, it's not in the middle, but it's still considered as symmetrical. Okay, so naming of alkenes on the bottom of page 340. It says for IUPAC, okay, that's International Union of Physics and Applied Chemists. I believe that's the abbreviation for that. Okay, nomenclature purposes, the longest continuous chain is redefined as the longest continuous chain containing both carbons of the double bond. Okay, so a lot of this is going to repeat itself from that of alkanes. For some alkenes, this chain may not be the longest continuous chain of carbons in the molecule. We'll explain what that means in just a moment. Okay, the family ending of the names changes from ane to ene. That's no surprise. And ane is a saturated alkane. So we changed the suffix to ene. That's why we said pentene instead of pentane. The longest continuous chain is numbered from the end nearest the double bond. The double bond is going to take priority. That has to have the lowest assigned number, is what that's saying. The position of the double bond is indicated by placing the lower of the two numbers for the double bond carbons in front of the base name of the compound. For ethene and propene, the number 1 is not required to indicate the position of the double bond because there is only one possible placement of the double bond. The names, substituents, are used as prefixes preceded by numbers that indicate the positions on the longest continuous chain. A compound with two double bonds called diene is given the ending pentadiene or hexadiene or heptadiene instead of ene. Two numbers are then provided by specifying the position of the double bond. A cyclic compound with a double bond in the ring is named as a cycloalkene. Numbering of the ring starts at one of the carbons of the double bond and proceeds through the other carbon of the double bond to substituents on the ring in the direction that yields the lower numbers for the substituents, or I prefer to use derivatives. So, going through that naming, the rules for that. Did anything seem, I don't get it? Was it pretty straightforward? You've applied it, you just didn't know you were doing that. What I mean is this, okay? So let's say, for instance, the difference between this, oops, I made a mistake there. What's that? Yeah, this one's got too many hydrogens. I did that on purpose. I just wanted to see if you would catch it. I can't get anything past you three, especially the official. Everything stops here, huh? Yeah. But them two get into it at all, or because you said you laugh at the two. Well, either one.
This morning it was verbal, but they do physical sometimes.
But do you get to officiate there, or you just laugh at them?
By officiate, you mean break it up?
Yeah.
It depends on like how bad it is. 'Cause, like I can normally tell like who with this fight somebody's gonna cry. So like if that happens, I'll be like, guys, stop. So like if it's not, then
Okay. Huh. That's why I called you the official walkie. Yeah. Okay, so what we're getting at earlier was the idea that if there's, remember we said if there's no numbers indicated writing after if there's nothing indicated after the number, that's just saying where your bond is. Okay, so when we apply those rules, the longest continuous chain is what? Okay, so we know that the prefix then is P. We're not going to go any further. Okay, so there's our parent chain. So this is our functional family, which we know we changed the suffix from ANE to ENE. Okay, but we can't just leave it like that because that double bond is not after the first carbon. Okay, I know the rules go into saying that you don't have to do that for ethene and propene. I do believe it's just common knowledge. You could say butene, pentene, hexene. You're just saying that just for this. I always like to use this example. Okay. You can write a 1 there, but it's not necessary. It's just understood that you've got one sulfur there. So for the same reason, if you don't write anything after the number, you're just saying it's after the first carbon. But in this case, that double bond, is it after going this way or this way? Left to right, and that double bond occurs after which carbon? The second one. So if there's nothing written after that number, that's just telling you where that bond is located. Okay? That's different than what we see down here. Okay? Maybe I should switch that up just a little bit. Well, no, we can leave it like that. I was thinking maybe I should put it here. But this is okay. Pretty straightforward. So, just like we said, is this asymmetrical alkene or symmetrical? It's symmetrical because it's not after the first carbon. Okay. The bottom one is going to be named very similarly because how many carbons do we have? We got 5. And notice, does it make any difference if we go up and over like this or just straight across? It makes no difference. Okay? You could say it's either a branched chain or a straight chain. So you correctly said 5. Okay? So we know there's our parent chain. Here's our suffix. Okay? But how is this different than the one that we have up here? Can we just put 2-pentene on this one? The answer would be no. Okay? Because as we locate that second carbon, again, this is our organic family right here that says that that is an alkene. But how do we have to name not just our double bond, but we have to account for this derivative, which is a what? It's a methyl group. So, what do you 2-methyl, 2-methyl. Right. So what we're getting at here is if you don't see anything after that number, that is telling you where that double bond is. So if we reverse engineer this, ENE is telling us, okay, we've got an alkene. There's a double bond somewhere. This is telling us our parent chain that there's supposed to be 5 of them. There's nothing written, I almost said nothing. There's nothing written after this 2, so that's referring to where that double bond is. And then this says we got a methyl group on the second carbon. So, okay, we have a double bond somewhere. There it is, second carbon. Here, there's supposed to be 5 of them. 1, 2, 3, 4, 5. There they are. Methyl group on the second one. Here he is, right there. Okay, we went through that really, really fast. Do we have any questions over that? The big thing to remember, since there's something written after this 2, that means we got to make sure we put that methyl group on there. There's nothing written after this 2 telling you where that double bond is located. Make sense? All right. So a couple more things I want to go over. Gesundheit is this as examples. If you get in a hurry, it's going to be very easy to make a mistake on these. Okay? Now I think it's written correctly. Yep. Does that look right? Does every carbon have 4 bonds? And I do believe that is true. Okay? So, the first thing you're going to want to do is find what? Your longest continuous chain, which would be what prefix? Okay, so we know that it's HEP for, I'm afraid I'll have enough room over here. HEP, you're saying there's 7. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, so we know that that's right. We know the functional family of this compound is an alkene, but what's significant about this one as opposed to this one, other than that it's more carbons? There's 2 double bonds, so we know that what do we have to do in the naming we read in the rules? How do you change, like, pentene to, or excuse me, heptene to hepta what? It was di. Okay, it's the next to last bullet. Diene. It says, okay, a compound with 2 double bonds called a diene is given the ending adiene or adiene or however you want to pronounce that instead of ene. 2 numbers then are provided for specifying the position of each double bond. Okay, so we know it's hepta diene. Okay, so where are those double bonds located now? 1 and 3. That's correct, because it's going back this direction after the first after the third. So we have to do 1, 3 dash heptadiene. Okay, and notice there's nothing written after here, so we don't have any derivatives or substituents or anything branching off of those. So these two numbers then are referring to where those two double bonds are. So this is saying there's two double bonds. This says there's 7 carbons, and then this tells you where they're located when we reverse engineer that. Are we good with this? Okay, so one of the last things I want to go over, okay, is I want you to look, and you may want to keep this open because this will help you on this paper I'm about to hand out. Keep it open around page 341 when we're done here. But what I want you to look at is on page 345. There, they show you the difference between cis and trans compounds. Okay, so on page 345, okay, what do you notice about the cis-2 pentene? What are the hydrogens doing in a cis compound? They're both doing what? Around the double bond. The hydrogens are doing what? Pointing, not down. The same way. They're both pointing up. Okay? So what we're looking at here is this. It says, okay, so we know there's a hydrogen here, there's a hydrogen there. Okay? We've got a methyl, well, not, that's part of the parent chain. So 1, 2, 3, 4. They just put an abbreviated formula on there. But notice in a cis compound, the hydrogens are both pointing up. Okay? How is it different in a trans compound right next to it on page 345? One points up, one points down. That's correct. So then what's different with that is in a trans 2 pentene, you've got one pointing up and one pointing down. Okay? So we're not going to go into why that's important. We'll talk about that tomorrow. Okay? And there's no reactions, on this paper. It's just all naming. So there's no reaction mechanisms. We'll dive into that a little bit tomorrow. It says work on worksheets and reactions. So that's what we'll be doing tomorrow. So you've got the rest of the hour to work on these papers, do journal entries, whatever you feel you need to do. We'll pick up with this tomorrow.